Hello there, welcome to episode 3 of the machine learning problem solving series. In this video, we'll understand and implement the softmax function, a key concept used in deep learning and classification models. Softmax converts raw neural network outputs into probabilities, helping AI systems make meaningful predictions in tasks like image classification and language processing. Now, why do we need softmax? Neural networks produce raw values called logits, such as 2.1, 0.3, and negative 1.5, like here. These values are not probabilities because they can be negative, and these do not sum to 1. We need a method to transform these outputs into meaningful probabilities. That is exactly what the softmax function does. Now, how does softmax function looks mathematically? Softmax function works by exponentiating each logit and then dividing by the sum of all exponentials. This ensures every output becomes positive and all outputs together sum to 1. Higher logits receive larger probabilities, making the model's prediction more confident and interpretable. Now, how does the step-by-step computation of softmax from logits look like? So we'll be computing softmax using the logits 2.1, 0.3 and minus 1.5. First, we calculate the exponentials, which approximately become 8.17, 1.35 and 0.22. Next, we add them together to get 9.74. And after that, we will be dividing each of them by 9.74. So these exponentials are divided by the sum. These values now form a valid probability distribution. Now, let's take an example of how softmax is used in image classification. Suppose a neural network is classifying an image as a cat, dog, or bird. After applying softmax, the probabilities become 84%, 14%, and 2%. So 84% is for cat, 14% is for dog, 2% is for bird. Since the cat class has the highest probability, the model predicts the image as cat. Now, where softmax is placed in this neural network architecture? So softmax is usually placed at the output layer of a neural network. The earlier layers extract features while the final layer produces logits. Softmax converts those logits into probabilities. During training, it is commonly used together with cross entropy laws to improve prediction accuracy. So now let's begin with the implementation. So let's begin implementing softmax function. As we have seen before, the formula for the ith element is softmax is equal to e to the power z, which is exponential of an element, upon the sum of all the exponentials for that array. And we will be following an important note here. For numerical stability, we subtract the maximum value from all elements before computing. So the new formula becomes exponential and m the new in the power, instead of normally zi, we will be subtracting the maximum value from it. This prevents overflow when the input values are large. Now let's begin. So what we have to do is we are given a z, which is numpy array. Now we have to calculate the shifted array. So shifted array will be z, which is the original, minus np.max of z. So what this does is this subtracts maximum value from z from every element of z or z. Next, we'll be calculating exponentials for all elements in shift. So for this, we'll simply writing np.exp and then shifted. And after this, we will be returning np.round, then exps divided by np.sum of exps. And since we have to return it to 4 decimal places, so 4. Now let's test it. So yeah, it has passed the test cases. Let's submit it. And we have successfully implemented Softmax function. To conclude, the softmax function transforms raw outputs into probabilities that sum to 1. It is widely used in multi-class classification problems and plays a major role in modern deep learning systems. Understanding softmax is essential for building and interpreting neural network models. Thanks for watching.